A number of ways of 5 different employees can sit into 4 indistinguishable, means identical, offices where any office may have any number of persons, including 0. So here, suppose they are distinct instead of indistinguishable. If it is distinguishable, let us consider here if there are 3 different objects, you have to put in 2 distinct boxes. Exactly 2 distinct boxes. How many ways are possible means number of ways of putting 3 distinct objects in 2 distinct boxes so that no box is empty. Is nothing but number of onto functions. So here how many functions are there means 2 cubed, which are not onto means all maps to this box. It's not onto because one element will be free. All maps to this. So number of onto functions 6. So if these are distinct boxes, if they are identical boxes, 6 by 2 factorial, that is 3 possible ways. So the same logic I am using here to answer this question. So objects here, employees 5, offices 4. Here possibility is 4 offices means there is a possibility that 3 employees in one office, 2 employees in one office, other 2 offices may be 0. So here cases no office is empty. Then how many onto functions are there? To calculate onto functions, your domain contains n elements, codomain r power n minus nc1, here r minus 1 whole power n plus rc2 r minus 2 whole power n, this alternate plus. Here 4 power 5 minus 4c1, 3 power 5 plus 4c2 into minus 4c3 into, after that anyhow 0 you get. Here they are distinct, right? So if it is identical, what we do is 4 power 5 minus 4 into 4 by 4 factorial. 4 power 4, 256 minus 243, 32 into 6 by 24, which here 52 plus 192 244 minus 4. So 240 by 24, 10 possibilities. So second case, exactly all employees are adjusted in 3 offices instead of 4 offices. 3 power 5 minus 3C1 into 2 power 5 plus 3C2 into 1 power 5 by 3 factor. 243, 32 into 96 plus 3 by 3 factorial. 150 by 6, 25. Exactly 2 officers, 2 power 5 minus by 2 factor. 32 minus 2, 50. Exactly one office. That is only one possibility. Total 10 plus 25 plus 15 plus 1, 51 possibilities. Here it is root 3 plus root 2 power x, you take it as a. A plus 1 by a is 10. A squared minus 10a plus 1. A will be 10 plus or minus 10 plus or minus 4 root 6 by 2. 5 plus or minus root 3. It is root 3 plus or minus root 2 whole square. Root 3 plus root 2 power x is root 3 plus root 2 whole square, or root 3 plus root 2 power x is, here x value is 2. Here this you can write power minus 1. X value is minus 2. Solutions are, there are 2 solutions. Here area enclosed by the curve y into x plus 4 is 16. X plus y is 6. 16 by y here is 6 minus x. So here y equals 16 as x increases, y decreases. And another is y equal to 6 minus 6. Line is here or here, we don't know. So unless we solve it, we don't know. So let us solve. 16 by x plus 4 is minus x square plus 6x minus 4x plus 24. Minus 16 minus 8. Here x square minus x minus 4 into graph will be so they intersected x equal to minus 2 comma x equal to 4. So this area we have to find out. The area of ABCD is area under the line So directly it is trapezium area h by 2 into wherever you can avoid integration, avoid it just by calculating distance between parallel lines. At x is minus 2, it will be 8. X is 4, 6 minus 4, 2. Sum of parallel sides, 30. And area under the curve, minus 2 to 4, 16 by x plus 4 dx, 16 log x plus 4, which is 16 log 8 minus log, which is 16 log 4, which is 32 2 square, 32 log 2 to the base. So the final answer is 30 minus 32 log 2 to the base e. Suppose three equations are given, something like this. Suppose you eliminate y here, this is only for example's sake I am saying. And again eliminate y from here, you get the same equations. We say that system has infinitely many solutions. The same logic I am going to use here. 2x plus 3y minus z is 5. X plus alpha y plus 3z is minus 4. 3x minus y plus beta z is 7. So first equation, second, third. So I am eliminating x from this, multiply this by 2 and then subtract. So x get cancelled out. 3 minus 2 alpha y minus 7z, 5 plus 8, 13. So here it is. This is, let us say, fourth equation. Similarly, here you multiply this by 3 and then subtract. It's 3 into 2 minus 1 into 3. So we get 3 alpha y plus y. Here it is 9 minus beta of z minus 19. Say this. 4 and 5 represent same line. Then their coefficient ratio must be same. That is 3 minus 2 alpha by 3. 9 minus here 4th and 5. 3 minus 2 alpha by 3 alpha plus 1. It is minus 7 by 9 minus beta, which is 13 by minus 9. Here it is considering these two, 133 equal to 117 minus 13 beta. So beta is 16 by minus 16 by 13. So 3 minus 2 alpha into, considering these two, minus 19 is 3 alpha plus 1. 38 alpha is equal to 39 alpha plus 13. Alpha equal to minus 70. So what he is asking, 13 alpha beta, alpha is minus 70, minus 16 by 13, 1120, second option. Here eccentricity of hyperbola equal to 5, just rewriting in the standard format, 5 sine square theta is 1. So for hyperbola, eccentricity is a square plus b square by a square, that is 5 plus 5 sine square theta by 5, which is root of 1 plus sine square. For this, for ellipse, this after converting in standard format is 5 sine square theta is less than 5. So now A less than B, to find out eccentricity, we write. So from there, eccentricity is 5 minus 5 sine square theta by 5, which is 1 minus cos square theta. The given eccentricity of hyperbola is root 7 times ellipse. Eccentricity of hyperbola root 7 times cos theta. Squaring and simplifying. So we get 8 sine square theta is 6. Sine theta plus or minus root 3 by 2. So since theta is in first quadrant, theta must be pi by 3. Here it told continuous everywhere. Everywhere means in the interval minus infinity to infinity, everywhere it is continuous, which implies, so to find out constant, the turning points we'll consider if is continuous at x equal to 0, limit extends to 0 minus fx equal to f of 0 equal to limit extends to 0 plus fx. So 0 minus less than 0, a minus b cos 2x, f of 0 is 2, 0 square plus 0 plus 2. Once we substitute here, which is possible only when a minus b 0. If a minus b is not 0, it can't be finite quantity, it will be infinite, which cannot be equal to 2. So similarly, if is continuous at x equal to 1, limit extends to 1 minus fx, limit extends to 1 plus fx. 1 minus means less than 1. We get x square plus cx plus 2 is 1 plus means 2 plus 1, that is from here 1 plus 3 plus 2. From here c value is 0. So we got c value. Still I didn't get AP values. Let us simplify this. Once A is B, A into 1 minus cos 2x by x square, which is 2. So limit extends to 0, 2 sine square x by x square, which is 2. 2a is 2, here a is 1, which implies b is 1. So now we got ABC values, a plus b plus c will be 2. So we have to check its differentiability. Where f is not differentiable, we have to check. To check differentiability, place seems to be not sufficient. Let us try. So f dash x f of x, let me write here after getting a b values, 2 sine square x by x less than 0, x square plus 2, where x lies between 0 and 1, and 2x plus 1 for x greater than 1, which implies f dash x will be, so here it is 2 into derivative of direct differentiation sine 2x minus sine square x into 2x by x power 4x less than 0. Okay, it is 2x, but do remove this boundaries. Here it is 2 for x greater than 1. Now, left hand derivative at 1, 0 to is 2. Right hand derivative at 1 is also 2. So f is differentiable at x equal to 1. Similarly, at 0, if you check it, limit x tends to 0 minus left derivative, limit x tends to 0 plus fx is 0. Elsewhere, for example, between 0 to 1 polynomial constant sine square x by x square, this one, all are differentiable. So f is differentiable everywhere. So m equal to 0 we get. So final answer will be 2. Here, whose eccentricity is 1 by root 2, that is E is equal to, so he told A greater than B square is A square into 1 minus E square A square into E, he given 1 by root 2. From here 2B square is A square, this is one relation. So square of eccentricity, for hyperbola, eccentricity is this. So I think this information is excess, which is not required. 2b square is a square, here is 2b square. The answer is 3 by 2. Square of eccentricity is 3 by 2. Here 3abc are in AP, which is c minus b. These are in GP, b plus 1 by a minus 1, b plus. So what he's asking, arithmetic mean of a, b and c. That means here we have to find out ABC values from here, taking these two. Let us substitute here. So a minus 1 whole square is 3 times b plus 1. From here, whole square is b minus 1 whole square, 12 times b plus 1. Here is b plus 3 by 2, b plus 1 whole square. So, which implies b is minus 1 or b plus 1 is 12. So let us consider one of the case, b as 11. So in this case, 2a will be 7. Consider other case, we have other values. And regarding c value, c minus b is b minus a. 11 minus 7, c will be 15. Arithmetic mean of ABC, a 7, b 11, c 15 by 3. 18 plus 33 by 3, which is 11. Here it is. Y depends on fx. We have to find fx. 5 times f of x plus 4 times f of 1 by x is this. To simplify this, replace x with 1 by x. We get 5 f of 1 by x. Here 4 f of x will be 1 by x square minus 2. So we get here it is 25 f of x plus, then subtract minus 16 fx equal to 5x square minus 10 plus 8. 9 f of x is equal to 5x power 4 minus 10x square minus 10 minus 2x square. So 9x square f of x. So it is 5x power 4 minus 2x square minus. So here we assume that y as 9x square f of x, which is 2x square minus. For increasing, we have to check dy by dx 4x, which is 4x you take common. So 4x into root 5x minus 1. So these are all odd powers. By using Vedic curve, 0 minus 1 by root 5, 1 by root 5. The curve will be like this. So where dy by dx graph, where it is positive means f dash x positive if x belongs to union 1 by root 5 to infinity. That means f increases in above interval. Shortest distance between the lines, here this is one line, here it is L1. Shortest distance is perpendicular distance between the two lines, two lines. It is passing through the point lambda 21, another is passing through the point 231. So it is shortest distance line L. So here shortest distance is AB, projection of PQ on L. So PQ will be here lambda minus root 2, just uh, lambda minus root 3, 2 minus 1, 1 minus 2. The DRs of this line. So here it is PQ dot L by mod L. So this L is perpendicular to L1, L is perpendicular to L2, L is parallel to. So here L1 is DRs of L1, DRs of L2 is L1 bar cross L2. 3 minus 3 into minus 3. So which is 3 times I plus j plus k. So here it is. In the vector along AB will be I plus j plus k. So it is, even if I take 3, I don't take 3, they get L by mod L, they get cancelled out. Shortest distance will be PQ dot L by mod L. That is lambda minus root 3 1 minus 1 1 1 1 by modulus plus 1 minus 1 by root 3, which we given it as 1, shortest distance. Lambda minus root 3 is lambda is 2 root 3, comma lambda is 0. Sum of the values will be 2 root 3. Here, relation on the set is defined as B is divisible by A. So if I take 1, it is divisible by every number, 20 numbers. If I take here 2, then 2, 2, 2, 4, 220. If I take 3 here, 3, 3, 3, 6, 3, 18, 4, 4, 4, 8, 4, 20, 5 if I take 5, 20, you have 4 numbers, 6, 18, 7, you have 2 numbers, 8 if you take 2 numbers, 9, 1, 10, 20, 10, 10, sorry, 6, 6, 10, 10, 10, 20. You have 2 numbers. Now onwards, there is 11 not possible, all 11, 11, 12, 12, like this, 20, 20. So totally how many? 36, 41, 41, 45, 48. Here it is 856 plus this 10. 66 terms are there. And R2 here is A is integral multiple of B. R1 minus R2 will be R1 minus R1 intersection. R1 intersection R1 intersection R2 means set of all ordered pairs such that A divisible by B and B divisible by A. This is possible only when A equal to B. A equal to B means here you have 1, 1, 2, 20 to 20. So, so now there are 10, 20 numbers are there. Final answer will be R1 minus number of elements will be 66 minus 20, 46. So here let the line of shortest distance intersect L1 and L2. Here you have two lines are given. So L1, L2, shortest distance line is PQ. Which intersect these two lines become a Q. This line equation he given R bar equal to A bar plus TB bar means it passes through A parallel to B. Passes through A and parallel to B. That means line DRs of this. This one is passing through 4, 5, 6 and parallel to 1, 1 minus 1. See, this is AB. So here it is L1 to L is a perpendicular to L1 as well as L2. DRs of L are proportional to A bar cross B bar. A bar represents line vector 1 minus 1 1. Here it is 1 1. So here it is 0 plus k into 2, which is 2j plus k. So I got vector along the line. So PQ bar, so R bar is any point on the line. PQ bar will be, here it is just subtraction P and Q, that is 3I plus 3J plus 3K plus mu into I plus J minus K minus lambda into I minus J plus K. So it is I into minus lambda J into 3 plus mu plus lambda 3 minus mu minus lambda. So already L is represented by 2j plus 2k. Both the vectors represent same line. 3 plus mu minus lambda by 0, lambda by 2, 3 minus mu minus lambda by 2. So once you simplify this, you get mu minus lambda as minus 3. If you simplify this, mu plus lambda is equal to, which implies mu plus lambda is 0, lambda is minus mu. So lambda is minus mu, mu becomes minus 3. Mu is minus 3 by 2, lambda is 3 by 2. Now, what we have to find out is midpoint of PQ. P will be, in place of lambda, you substitute 3 by 2, I plus 2j plus k plus lambda here is how much? 3 by 2 into I minus j plus k, 5 by 2 I, 4 minus 3 by 2 half, 9 by 2. So these are coordinates of a point P. Here, in place of mu minus 3 by 2, if you substitute 6k minus 8i minus 3i, 5i by 2, 10j minus 3j, 7 by 2. Here it is 6k, 12 minus 12 plus 3, 15 by 2. So the midpoint here is alpha plus beta, alpha, beta, gamma, 5 by 2 plus 5 by 2 by 2, 8 by 2, that is 4. Here it is 24 by 12 by 2. The 2 times alpha plus beta plus gamma is 5 by 2 plus 8. We get 16. We get 21 as an answer. Here it is m equal to 3. M is related to first terms, n is related to second terms. So third term of first series coincide with fourth term. So first common term is 11. To get second common term, first series if you take, that is sixth term, a plus 6 minus 1 into d, that is a3, 5 into d will be 4, 23rd. So like this 11, 23, up to some terms we have a common terms. What will be the maximum number of terms? Again, 11 plus n minus 1, it should be less than 403. So n minus 1 into 12, 390, where it is 403, 392. So roughly 392 by 2, it is 36, 32. So that is n is less than or equal to 33. That means number of common terms will be at the most 33. So less than equal to n by 2 into 2a plus n minus 1 into d. 33 by 2 into a here is common first common term, 22 plus 30 into 32 into d. So here it is 22 plus 394. So after simplification, we get a 6699. In this one, first, don't get afraid by seeing this type of questions. Whenever fractional part is there, left and right limits we have to find out. Limit extends to 0. Cos inverse of 1 minus fractional part of x whole square Sine inverse of 1 minus fractional part of x by step of x, sorry, fractional part of x into fractional part of x whole square. So fractional part of x is x minus step x. Limit x tends to 0 plus. Here it is 0, 0 plus will be limit x tends to 0 minus. It will be 0 minus. 0 minus means something very near. So we get plus 1. First, let us find out. If I take left limit x tends to 0 minus cos inverse 1 minus, so sine inverse 1 minus fractional part of x by fractional part of x into 1 minus, like this. Now let us substitute. 0 minus means it is 1. 1 minus 1 cos inverse 0 we get, which is pi by 2. Sine inverse 0 minus, that is 1. Sine inverse 0 you get. It is 1 minus 1. 1 minus step of x approaches to plus 1. Okay. So by here, step of x 0 minus, you get 1. Here it is sine inverse 1. 1 minus 1, 0 square. So here you don't have problem, right, as is. So now sine inverse 1 minus by 1 minus into 1 plus fractional part of x. Here it is 1. That also you can take outside. Limit x tends to 0 minus by 1 minus fractional part of x. Here it is of 0 by 0 format. So x tends to 0 minus 1 minus fractional part of x. Here you take fractional part of x as y. X approaches 0 minus y approaches 1, then it will be limit will be pi by 4. Sine inverse 1 minus y by right. So which is nothing but pi by 4 into 1. You get left limit is pi by 4. So regarding right limit 0 plus cos inverse sine inverse 1 minus fractional part of x by step of x into 1 minus, where we don't get 0, we get a number. X approaches 0 plus, it is 0. Your cos inverse 1, 0, we have a trouble here. Sine inverse 1, pi by 2, we don't have trouble. Here x approaches 0 plus, it will be 0. So in this one, you can write it as directly pi by 2. Limit x tends to 0 plus 1 minus fractional part of x whole square by fractional part of x. So now you get 0 by 0 format. As usual, fractional part of 5. X approaches 0 plus y approaches 0 only, which is pi by 2 into y tends to 0 cos inverse y you get. So now 0 by 0 form, you can apply a last petal rule. 1 minus 2y by 2. So minus 2y by derivative is 1. So as y approaches 0, here cos inverse 1 0 by 0 format. Cos inverse derivative minus 1 by this, again minus 2y. So y derivative is 1. You get here limit y tends to 0 pi by 2, 2y by under root 1 minus 1 0, y power 4 minus y power 4 minus 2y square 2. Limit y tends to 0 pi by 2 into 2y by 2y square. Y if you take common 2 minus y square. So pi by 2 into 2 by root 2 you get after substitution. Pi by root. Then finally here it comes up 32 by pi square. Left limit we got pi by 4. In right limit we got pi by root 2. So 32 into pi square plus this pi by root 2 pi square by 2. 9 pi square by 16. After simplification we get 18. Here, coefficient of x power 30 in this expansion, x plus 1 power 6, x square plus 1 whole power 7 by x power 6, which is same as x plus 1 power 6 So here we don't find common factors for simplification. Seems to be laborious process. 6c naught h power 6, 6c1 h power 5 so on. 7c naught 7c1 7c2 h power 10. Seven C six six square 7c7. Whole thing multiplied by HC naught h power 24. HC1 x cube whole power 7 X power 3 whole 18, 3 difference. So here in the first bracket, highest power is this. In the second bracket, x power 14, that is x power 20. So to get x power 36, minimum power required is x power 16. But here these terms are useless. It actually power 8 means 9 terms are there. So only we have to consider 3 remaining 6 we can eliminate it. Now let us concentrate on first term. 8c naught x power 24. We require x power 12 from the product of first two expansions. X power 12 means that is x power 6 into x power 6, that is 6c naught into, we require x power 24, 12 we require. X power 5 odd terms useless because all even powers in the second bracket. So here 6c2, here x power 4 you get. So x power 8, 7c3, 8c0. So 6c2 over, then 6c4. C4 means x square, we require x power 10. 7c2. Again here 8c0. 6c0 and x power 12. That is 7c1. So similarly with this, the terms 21 means we require 15 to have a 36. So we require x power 15 from the first two product of two expressions. Where 6 is there, 9 we don't get, only even powers in the second bracket. X power 5, that is minus 8c1. 6c1 into 6 power 10 here is 7c2. Even terms useless here. 6c2 useless. 6c3, which is here 6c2 x power 4. 6c3 x cubed. So we require 12. 12 you get a 7c1. 6c5 x, and we require x power 14. One more term. 8c2 x power 28. Sorry, 18. So we require 18 plus x power 18 coefficient we require. 18 means here x power 6 into x power 12. That is 6c0. So here with the even terms only possible, that is 6c2 x power 4, 14 we require. 8c2, 6c4. 6c4 means x square you get. X square. We require x power 18. If I take x square, here is 14 not possible. Only this many terms what you have. After simplification, so I did this simplification, but you just, I'll write the final values. Here this after simplification, we get 882. Here this is 2176. Here we get 616. Finally, coefficient of x power 36 will be 882 minus 2176 plus 616, which is